Howdy, howdy. Oh, really? Yay. If you have two variables of the same type, then the addition happens, or the math on them happens just fine, right? Multiplication, division, whatever. Or if you're passing something to a method and it's of the same type, great, no problem. If you have something like this, right, say you declare a method like this, who cares what it does, right? And it takes an int, then when you call it from within main, right, if you declare another int inside main, and then you call something with it, no problem. They're of the same type. If it's of a different type, if it can be converted without loss of data, C# will go ahead and provide the conversion. Like if it wasn't an int, instead it was a short or a char, some other kind of smaller integer type, something that occupied fewer bytes, it'd go ahead and convert it just fine. So if we did this, character A is equal to, some letter like that, then by the time we got into here, X would equal whatever the ASCII value of C is, which happens to be 67, I think. So if we printed X out, it would be 67 because this would be promoted to an int just fine. The reverse is not true. If we write another function, another method, that takes a character, does something with it, sure, if you pass in, whoopsie, if you pass in a character, great, there's absolutely nothing wrong with that, right? That'll work just fine. You're passing a character as your argument, the parameter is a character, great, works perfectly. What if you tried to pass in an int, right? You have an int. Even if it's a valid ASCII value, you could probably get away with declaring it like that, or you could certainly, say this is a 67, which is an ASCII C. But if you try to pass it in like that, if you try to pass this character in, since the potential for data loss is there, since a character is just like a 2-byte data type or a 1-byte data type, I think it's 2 bytes in C# so that it can support Unicode, and an int is a 4-byte data type, it can't be shoehorned into it. And unlike C++, which will go ahead and do so, it may give you a warning about it, right, when it's compiling, but it'll go ahead and provide the code to, whack off the extra bits, and it doesn't care if the corruption happens. C#, like Java, will not let it compile if you have that state to where you're trying to stick a 4-byte data type into a 2-byte data type. What about doubles and floats? What if we have a function that takes an int and we try to pass it a double, right? So we call D2 3.14159. The compiler will flag that as an error because, well, for one thing, that's an 8-byte data type. An int is a 4-byte data type. But if we don't, even if we declare that as a long, which in C# is 8 bytes, unlike Microsoft C, where it's 4 bytes, even though we have enough bytes, the data type is completely different internally. This supports exponents and fractional values. So there's no way that that could be converted to that without fear of data loss. So the compiler just won't do it. You can force the issue. You can say, I want you to be turned into a long so that I can pass you in there, right? This cast, just like casting a piece of lead, changing its shape, changes that data into a long so that it could be accepted as an argument for this parameter variable. And that works, but what would happen? It would chop all that off, and by the time we got here, X would only equal 3. But at least we knew that was going to happen. We explicitly said, there we go. So we knew it was going to happen, so it's our fault if it doesn't do what we want. So data can be promoted up the hierarchy, the complexity chain. And I'm sure that the slide has a different term for it. I should just flip back to it. No problem. C# will provide the code to do that. Not demoded though, not knock down the complexity chain. It will not convert a long to an int automatically, implicitly. Same thing happens when you are multiplying values together, doing any kind of math to them. If we had this, double z is equal to 1.23 times 4. These are dissimilar operands. They will both be converted to a unifying data type that can be multiplied together. So the lesser data type will be promoted to a greater data type. This int will get promoted to a double, no problem. And then 1.23 will be multiplied by 4.00 and the result stored in z. So, arithmetic with operands of dissimilar types, C# chooses the unifying type for the result, which is going to be the larger data type, the more complex data type, the one that occupies more bytes and supports floating point numbers if necessary. That's called implicit or automatic convert, the non-conforming operand of the unifying type. So the type with the higher precedence wins. If you have an int being multiplied by a double, the result's going to be a double. That's called an implicit conversion or implicit cast. If you had reason to, you could convert that to an int. And then the result would be an int, right? Because this value gets turned into an int, which when multiplied by another int, gives you an int result. Don't know why you'd want to do that, but you know, if you needed to, sure. So an implicit cast, automatic transformation that occurs when a value is assigned a type with higher precedence. If you have an int and you're trying to store it in a double, no problem. It'll provide the code for you. You don't have to sweat it. An explicit cast is when you go ahead and give it a data type, and you do that to prevent a compilation error, a syntax error. It will not compile this unless we have that int there if we're trying to store a double into an int, because data loss could most likely occur, right? Lose the fractional component, or it's too large to fit into an int. We have to tell the compiler, yeah, we know what we're doing. So we have to cast it. So for some reason, we want to take our bank balance, which is stored as a double, an 8-byte data type, and we want to store that result divided by 4, and we've decided quite foolishly that we want to store the result in a float. Well, we would have to convert the result of this to a float because we were multiplying a double by an int. The int would get converted to a double, the math would happen, the result would be a double. We would call it a syntax error because it would be trying to store it in a float unless we explicitly cast it. And why do I say that's foolish? Because of rounding errors. I think I've already given that speech about rounding errors. But if you have this, 1 over 3, we can't represent that exactly, right? Can't do that. So, you know, with a limited amount of RAM, say we had some kind of thing that could hold up to 8 decimal types, or 8 decimal values, or heck, even just that, right? That was the precision of our decimal data type. And then we said 1 over 3 plus 1 over 3 plus 1 over 3. Then when it did the math, it would take that, it would add that, it would add that, and you would get 0.999 as your result. We expect 1/3 added to itself 2 more times to be 1. And so if we print it out, you know, double result is equal to, or double error, you know, is equal, and we could actually, nah, we're not going to bother, is equal to 1 minus the result of these things, right? But 1 minus 99999, whatever we stored that variable in, is going to show up as 0.001, whereas we would have wanted it to be 0. That's a floating point error. A float has about 8 digits of precision. A double has about 15 digits of precision. So you would have, I don't know if that's 15 or not, but in this situation, you'd have that much error. when you try to get it to happen. And that's just doing decimal math, which is not what computers really do. They do binary math, right? So this value would be converted to a binary result, a binary representation, which is based on powers of 2. And some things store just fine in powers of 2 and some don't. 1/2 stores in power of 2 just fine. 1/4, 1/8, right? All of those would just work. I bet even 3/4 would work. But anyways, there are only certain values that can be cleanly represented in a floating point variable data type without fear of rounding errors. So never use float unless you absolutely have to. Just don't. There's no reason to. That's why the default data type, if you type in a decimal in your code, is a double. So the char data type holds a character, any single character. I believe it's a Unicode data type in this language, so it's actually 2 bytes for it, but just a character. It says that the character cannot be used in arithmetic because the 9 is a text, not a number, but you could convert it to an int if you had to. You could use casting, and then it would take that 9 and whatever the ASCII value of 9 is, I forget, 48, 49, 51, whatever it is, it would be used for that. So an escape sequence is a character, or it's a series of characters that begins with a backslash, and the most famous one is \n, and then there's another one, \t for tab, \0 for null. A should ring the bell, it should make a beep. You could try that. Form feed, well, we're not using printer, so form feed doesn't do much. Carriage return should theoretically return the cursor to the beginning of the same line we're on, rather than go to the next line. DOS and Windows, a lot of Windows apps store new lines, like if you open up Notepad and you type things in, as pairs of carriage return line feeds. So /r/n inside the document, inside the bytes of the document. However, Linux and Mac and a lot of other Windows programs just use /n to go to the next line. And so sometimes you will open up a document and you will see that all the carriage returns have been stripped out, and you opened it in Notepad and it looks just like one great big long line. It's because it was created using an operating system or a program that does not have both /r and /n in them. Horizontal tab and a vertical tab. Again, we're not going to use vertical tab. Double backslashes and backslash single quote and backslash double quote. It'd be a good time to actually launch. Is this lecture D or E? D? As in dog? Alrighty. Yeah. I already have a lecture D, so I'm calling it CS_lecture D for C#. And I did not mean to create a 132 app, so I'm canceling that. I'm going to do it again. It's C# console app. So what if I wanted to do this? What if I wanted to store a file name? String space fn equals quote C colon backslash temp backslash new file dot txt end quote end. What am I missing? Okay, yeah, it's assigned but never used. It's not an error, it's just a warning. Well, let's print it out, right? CW tab tab to expand to console.writeLine. File name equals curly brace 0 in curly brace, end quote, comma, fn. You know what, I wonder if it's going to print it perfectly. Let's find out. And I forgot to put my read line at the bottom, so I need to run it without debugging. Debug start without debugging. Yeah, look what it did. It did exactly what I was expecting. C:, imp, ufile.txt. The /t was treated as a tab, and the /n was treated as a new file. So to fix that for its display, we can embed the escape sequence for a backslash, which is a double backslash. It's kind of like, there's the beginning of my escape sequence. Nope, just fooling. I just want you to treat it like a backslash. That'll work. Now to print what we want. There is another way of indicating that a string should not be interpreted with escape sequences in it. And gosh, I remembered what, I wish I remembered what it was. When I say that to y'all, if you wanted to store a file name in a string, have any of y'all seen a way of doing that without using the double backslashes? Not a quiz question, I just don't remember. All right, alrighty. Let's Google that and see. String for file names or for paths, C#. Oh. @ sign in front of it. If you put an @ sign, and this is very specific to Windows or C#, if you put an @ sign there, then you don't have to expand these with escape characters for them to be treated appropriately. The @ means, take this literally. Don't do it as something with escape sequences that need to be converted. Let's add our read line at the bottom so I can just run it my favorite way. Console.readline, parentheses in parentheses. All right, there we go. It printed it out. Now what if I wanted to embed quotes in my little output here? Like, what if I wanted to say hello in quotes for some stupid reason? I can't think of a reason, but we're going to do it. Console.writeLine, parentheses, quote, and I wanted it to say quotes and double quotes. Hello. We can see that that's not going to work, because it's treating this as the opening quote and that's the closing quote. So if you want to embed double quotes inside of a string like that, you have to use the escape sequence, which means double quotes, which is just \quote. You can do the same thing for single quotes, \apostrophe. So now it's quote, and then the escape sequence for a double quote. Hello, the escape sequence for a double quote, followed by the real terminating quote. And we get our little message, hello, right there. So internally in memory, if we have this string, or if we just do this, console.writeLine, parentheses, quote, ABC, like that. This is an array of characters, or it is stored in memory at a certain point as an array of characters with the values 65, 66, 67, followed by a 0, a null character to mark the end of the string. Otherwise, how does the computer know, right, that this was the last character in that string? So it's called a null terminated string, or a null terminated character array. So if you have a double quote followed by a series of characters and then another double quote, there's an invisible 0, 0 tacked onto the end of it, a byte or a short with a value of 0 after it. That's just a null character. So that's an A. If we went to ASCIItable.com, that's a B, that's a C. I'm not expecting you to memorize those values. Just want you to know that every string between quotes is terminated with a 0, with a null set, which means that this is not actually just 3 in length. In memory, it's 4 in length, but it's treated as 3 in length for all purposes. And if we ask for the length of that string, it would return 3, because it would count up to and not including that. We could access element 0, it would print out, an A. If we accessed element 1, it'd print out a B. If we accessed element 2, it'd print out a C. And if we accessed element 3, which you shouldn't do because it's past the end of the string, it'd print out a null. Internally, that character array, you don't have to type this, is stored as, which are the ASCII values, the Unicode values, but Unicode, ASCII is part of the Unicode character set. The first 127 values of the ASCII character set are the Unicode standard, which are the ASCII values for A, B, C, followed by null. And if I'm going to keep saying ASCII value, I'm going to go to ASCIItable.com just to remind ourselves of that. See, A is a 65, B is a 66, C is a 67, and a good old 0. It's called a null. Indicates the end of the string.
We have 65, 66, 65.
Yep. Yeah. If you want to see those values, you just go to ASCII with 2 I's, ASCII table.com. All right. Excuse me for a moment. All right, I just noticed something strange, which is that for a few students, they don't have to add console.readline at the bottom of their code to prevent the window from closing after you press start. Right. But I had to. So technically, I should put a print statement that says press, any key or press return or whatever. I'm going to leave it alone. But that's what that's there for. If your window was closing, you'd want to stick this at the bottom. Oh, and while I'm looking at it, I always add these comments. I know it's a little bit tedious, but this is the end of main. This is the end of the class. And this is the end of the namespace. Just because I know that I will wind up with getting the error, hit into file while, scanning code or whatever, which means not enough curly braces or that we hit too many of them. So the char data type, they're actually stored as 1s and 0s in memory, just like everything else in a computer. All numbers are stored as series of 1s and 0s. And I kind of really don't want to do the lecture over what binary is. But I will mention that having something like this would be really tedious to try to memorize what that is. And so computer scientists in the, 40s, 50s or something, decided upon a standard called hexadecimal. And hexadecimal is something where every 4 bits can be represented by either a number or a letter. So I would have to, do not bother to type this. I would have to break it up into clusters of 4 bits just internally, just for my brain. I'm going to chop the last ones off. And if I know how to do this conversion in my head, that's a 5. This is a 7. Don't ask me how I'm doing this because I'm not doing that lecture. I'm just going to try to get you the idea. And that's a 12, which I think is a C. I could be getting some of these wrong. And that should be another 5. Okay, so that series of 0s and 1s can be represented on screen as a hexadecimal value. But behind the scenes, inside the computer's RAM, it's really that. So if you ever see a series of numbers and letters like that, where the digits are all 0 through 9 and the letters are A through F with nothing else, that's a hexadecimal number. If we go back and look at the slide, they're showing a hexadecimal representation of a character. Come on. They're saying that since a letter is an A, well, on the ASCII table, a capital A is a 65, and the bits that build up to a 65 can be represented in hexadecimal as 0041. And if we go back to ASCIItable.com, we will see that that is indeed the case. Capital A is a hexadecimal 41. Let's try to print out, I don't know, like or let's store into memory some letter that we really like, R, because we like row state. The hexadecimal value for R is 52. So in order to use, and you're never going to do this. Well, I mean, no, that's not strictly true. If you're, emoji are also Unicode characters, and everything that you can't type on a keyboard, the special typographic symbols and, Ukrainian diacriticals and whatever are not. So you may be needing to embed specific characters by their Unicode value. I've already forgotten what I said that R was. R is a 52. So if we go back to our code and we prefix 0052 by /u, we will be able to get an R out of it. And I'm going to go and do that just for giggles. I'm going to come here and I'm going to do, say, character CH, real creative, equals single quote, because characters are declared using single quotes, whereas strings are declared as double quotes. A character can only be one piece of data long, but that data could be a hexadecimal string representing the Unicode value. So /u 00, was it 53? 52. And then if I try to print that out, console.write line with a capital L. Can I just send CH to it, or do I have to build a formatting string? I think I've already established that you have to build a formatting string. Nope. Nope. If you just pass in one value, it'll do the conversion for you. Great. It should print out an R there. Yep. So this /u business, that's the Unicode for a capital R. Not a carpal. Don't have carpal tunnel syndrome. Capital R. Wouldn't it be fun to write a for loop that would print out the Unicode values of the first 1,000 values? This is totally silly. And I equals, let's start off at 65 because that's a capital A. So for, parentheses. Oh, why don't we just do it as a while loop? We're going to do int. We need some kind of counter. I don't think I've used I already. Int I is equal to 65, semicolon. While, parentheses, i's less than, let's just go up to 300. I less than 300, in parentheses, semicolon. Let's assign into CH the cast value of I. So CH equals, parentheses, CHAR, in parentheses, I, semicolon. And let's print that out just like we did here. I'm just going to copy and paste that line. Just because I'm curious. I want to see what those characters look like past the end of the ASCII table. The basic ASCII table stops at character 127. Tell you what I want to do though. I would like to print out both the character and its numeric value. So I'm going to actually add a formatting string after all. So inside the parentheses, it's going to be quote, curly brace 0, in curly brace, space, curly brace 1, in curly brace, end quote, comma, I, comma, CH. Just so that I can see the values. Oh, look what I did. I did my classic error. Every time I don't use a for loop, I do the same thing. What did I do wrong?
You forgot to increment.
I forgot to increment I plus plus. And there we go. We're seeing some cool ASCII characters here. If you ever needed to do, if you like the band Blue Oyster Cult and you need to put the 2 dots above the O, or maybe Motley Crue does it that way too, then you could use, Unicode value 246 to get that to happen. And we could let it go all the way to 1,000 to keep, seeing what it does. I'm curious. I'm going to increase my limit to 1,000. Print out all the characters to 999. Why not make it I less than or equal to 1,000? Just for funsies. Ooh, it hit a whole bunch of characters that it could not display, meaning that this window here is set to a font that does not have values for certain Unicode characters. And who knows? Who knows what a Unicode 982 is supposed to be? We could Google it up and find out. We see some repeats. But we could build a string that was composed of these special characters, right? We could add, if we want to do, that funny looking question mark or whatever that is, followed by, a little angle of a box. People used to draw, menus on screen and character-based menus, with edges like that. Okay, so enough of that diversion. The real point of this is that a character is just a value. It's just a 2-byte value, which, represents some kind of letter to be displayed on the screen. So the string data type is a series of characters. Now, unlike Java, you don't have to use some kind of dot equals method to compare strings. You can, but you can compare them directly as well. If you did this in Java, and don't type it because we're not learning Java. If you did this in Java, I guess I have it running. Changes are not allowed while the code is running. Okay, great. Why didn't you offer to kill the app? There we go. If you did this in Java, one thing, it's a capital S in that language, but let's say it wasn't. I'd be interested in finding out the difference between a capital S and a lowercase s in this framework. And then you did this. If s equals quote Bob, end quote, in that language, in Java, you'd have no guarantee that it would indicate that it was true. All it would be doing is comparing the memory address of that and seeing if it happens to match the memory address of that. The likelihood that it is not real high. So that is not how you compare strings in Java. So I have to break people of that habit of trying to do that because it works just great in Python. Doesn't work in Java, works just great in this language. We can go ahead and do that. You can create a string, and then if you feel like comparing it, you can use equals equals. If you want to see if it's different, you can do not equals. To compare strings in C#, you can use equal equal. You could also do this. I guess I shouldn't have uncommented that because I told you not to type in here. I'm doing a whole bunch of stuff with it. You can also use dot equals. If s dot equals parentheses quote Bob. Does the same thing. So to compare strings in C#, you can use equal equals, or you can use the dot equals method. You can also check to see if one string is less than another, meaning that if it was sorted alphabetically, things that begin with an A are less than things that begin with a B. However, it behaves kind of oddly, because if you look at the ASCII table, a uppercase A is considered, less than a lowercase a. An uppercase Z is less than a lowercase a. So if you were trying to sort your Beyonce albums versus your, there used to be an old, rock group called Zebra. If you named Zebra with a capital Z and then you labeled Beyonce with a lowercase b, then when you displayed your sorted data, Zebra would show up before Beyonce. It's kind of silly. It's just a side effect of the fact that when you're comparing characters to strings, they're being compared by their numeric value of that character. So there are libraries that you can use that will sort data, based on the representative, taking into account uppercase and lowercase, try to get them to sort correctly. What we would consider as humans correctly. So a string is considered equal to, greater than, or less than, so-called lexically, which in the case of letter values means alphabetically. Is it going to go into any greater detail about that? What are we trying to see here? Oh, this would just check to see if name 1 is equal to name 2. Well, name 1 is name 2, so it would print true. And then when we tried to compare name 1 to name 3, since those are not the same, it would be false. And it's saying that this is not recommended. I just went into a big lecture about why that it is okay. I guess since the textbook says it's not recommended, I'm going to recommend that we use dot equals anyways. Is there a dot equals ignore case like there is in Java? Can I do this? If s dot, nope. There must be an overload that allows it to ignore case. What do I mean by overload? When I start typing a function, like s dot equals, when I start typing a method name, the helper here displays several versions of it. The first version just takes that object and does a straight comparison. The second one takes a string. I'm not sure why we would ever pass it an object as opposed to a string. And then the third version lets you do a comparison type. You could create a comparison object that specifies what type of comparison you want to do, what kind of rules you're doing. Probably takes into account, like other character sets, Germanic, where, things with umlauts. I have no idea. I've never used a comparison type operator inside dot equals. We could Google it up and see. So substring. Now this is important. The other stuff was too. But you may remember, like from Python, where you can take a slice of a string, which is, a subset of it, by specifying, 2 numbers between square braces. Well, here we can use substring, and we would say our starting position is 0. And unlike slicing, the second number is not the ending position, it's the length. So if I say I want to start at 0 and give me 1 character, it's going to spit out a W. If I say start at position 1 and give me a length of 2, it's going to go to A and T. If you do 0 and you get out the entire length of the word, then you're starting at position 0. The length of this word is 5. But it's interesting, but it would give you 0, it would give you the whole thing. Starting with, 1 character, 2 characters, 3 characters, 4 characters, 5. And that's actually a little bit simpler to figure out in your brain than the Python way of calculating substrings. I believe that Java does it in a Python way, though, where you specify the starting position and the end position rather than the starting position and the length. So a named constant is just a constant. You use the word const here rather than the word final as you do in Java. And so if you wanted to, store the value of pi in your program, you could do const double. You would not capitalize. See, pi equals 3.14159. And then later on in your code, if you tried to change the value of pi, that would be a syntax error and it would not let you compile. Now there are more reasons to use the const keyword just for that. But if you have things in your program which should not change while the program is running, like the length of a buffer, right, or the maximum number of files your program is going to be able to open, put it in a constant rather than just hard coding that value in there. If the maximum number of files it can open is 15, don't put 15s all through your code. Instead, create a constant to hold that number 15 and call it max number of files. something like that. You know, I could come in here and do, you know, const int max files equals 15. And then whenever I needed to reference 15, I would instead reference it by its constant name, right? If parentheses max underscore files is, you know, less than 1,000 and do something magic, right? Whatever. We could refer to it that way. Far better. Stick these things up at the top, maybe even at the top of the namespace. If I was going to do this right, I would grab that max files and I would put it certainly above main right here so that I could refer to it from other classes as well. Oh, this program class, right, it can only you know, open 15 files, and I could ask it. So that's where I would put it if I was going to write this program, is I would go up here and I would, you know, add a constant. Right, so that I could use that. Can I stick it here? No, it won't let me stick it in the namespace. It has to be part of the class. All right, we need to about wrap up our lecture, but we're just about at the end of the chapter. I wanted to get to the end. No, we still got more slides to go. So a named constant, the goal is to make self-documenting code so that, you know, if I see if I is less than max files, I know what's going on. But if I see if I is less than 15, I don't know what 15 means. So you're trying to make your code easy to read. Enumerations are so important, I'm not going to skip past this part. So we're going to save the end of this chapter for the next lecture. The homework assignment is going to be pretty silly. I want you to have a string that looks like this. My favorite Star Wars character is Darth Vader. Now feel free to change that to, you know, Marvel character or TV character or book character. Change Darth Vader to something else. You can do something else, write some other string. Other names. And then create a bunch of strings using substring for every word in your sentence. So for mine, this is at position 0. And how long is it? It's 2. So, you know, string W1 for the first word of the sentence is equal to, we need to actually give this a name so that this will work. String data is equal to that. My favorite Star Wars character is Darth Vader. And then string W1 is equal to data dot substring, parentheses, starting at character 0, and it's 2 characters long. And then string W2 is equal to data dot substring. Well, where's the second word? If this is index 0 and that's index 1, that's index 2, then that's index 3. And how long is that word? 1, 2, 3, 4, 5, 6, 7, 8. Right. So starting at 3 and going out 8 characters. So in my example, this is equal to my, right? And then in my example, this is equal to favorite. So create a series of string variables to contain every word in the sentence using data.substring to extract the value and assign it as shown below. So get them all into strings and then print them out. Then print out each string, 1 per line. Now, is that an incredibly primitive way of getting data out of a string? Absolutely. You would not do it that way in real life. Instead, you'd use some function that would divide it up, right? Some function that would read the string and separate it by spaces or whatever. But does that make sense? Making eye contact with Simon now. Does that make sense? All right. All right. So That'd be the homework assignment. Maybe really short. All you got to do is figure out the starting position of each one of these, and you just got to remember that you start counting at 0. Alrighty, let's make a drop box and be done.